we're going to be looking at priority queues. This is a type of queue where each element has a priority. This behaves like the normal queue. You can enqueue from the back, you remove from the front, but you remove based on priority. So the item that has the highest priority gets removed first. So it doesn't really follow the FIFO principle, first in, first out principle, except all the priorities are the same. So let's go ahead and implement the priority queue. So have class priority queue. We'll provide our constructor. We'll have self. And we're going to initialize this to an empty list. So we'll have self.items is equal to an empty list. Now let's define the method for determining whether our queue is empty. So have def is empty. We'll have self. So we're going to be returning len self.items equal to 0. If this condition is true, it means that our queue is empty. Otherwise, it is not empty. Now let's define the method to determine the size of our queue. And we have size. And for this, we're going to be returning the length of the list. So we have return len self.items. Now we're going to implement the method for enqueue operation. So we have enqueue. We'll have self. We'll have the item that we want to enqueue, and we'll have the priority. And for this, we're going to be appending the item into the list. So we'll have self.items.append. But instead of appending only the item, we're going to be appending a tuple consisting of the item and the priority. So we'll have item, we'll have priority, and we'll close this. So this is how we perform the enqueue operation. Now we're going to be implementing a method performing the queue operations. So we'll have the queue, we'll have self. But before we perform a dequeue operation, we need to verify that the queue is not empty. If the queue is empty, we're going to raise an index error. So we'll have if self.is empty, which means it is empty, we'll simply raise index error. So have empty queue. But if the queue is not empty, we're going to perform a loop on the items in the queue to determine the one that has the highest priority and remove that item. When we're talking about priority here, we're talking about the item that has the least value of priority. For instance, if we have 3 elements, one has a priority of 1, the other has 2, the other one has 3. The one that has the priority of 1 has the highest priority. So we're going to start by assuming that the index with the highest priority is 0, which means that the first item in the queue has the highest priority. So we'll have HPI, which stands for highest priority index, is equal to 0. Then we're going to perform an iteration to verify the actual item with the highest priority. So we'll have for I in range, we're starting from the second item, and we'll have len self.items. And we have if self.items, and we'll have I here, and we use 1 to target the priority, is less than self.items. We'll have our highest priority index, and then we'll target 1. If this condition is true, it means that our HPI now becomes I. And this process will continue until we loop through the entire element in the queue. And at the end of the loop, we should be able to come up with the index with the highest priority. So we'll go ahead and remove that item. So have return self.items.pop. We'll have HPI, and that will be all. But before we conclude, let's implement a method that displays the content of our priority queue. So have def display. We'll have self, and we'll simply return self.items. So let's go ahead and instantiate this class. So have pq is equal to priority queue. And we'll start by determining whether our queue is empty. So have print pq dot is empty. We'll run it. You can see our queue is empty. Then we'll check the size of our queue. So we'll have print pq dot size. And run it. You can see it is 0, which means it is empty. Now let's display the content of our queue. So we'll have print pq dot display. And you can see we have an empty list. Now let's go ahead and perform some enqueue operations. So we'll have pq dot enqueue. We'll have 100 and we'll give it a priority of 2. And we'll run it. You can see we'll have one item here. We'll have 100. The priority is 2. So let's copy this and add more items to our queue. We'll have 4 items. So let's change this to 200. Change this to 300. And this one to 400. And I'm going to give this a priority of 1. And give this one or this other one a priority of 1. And run it. So this is what we have in our queue. So let's go ahead and perform a dequeue operation. And because this is a priority queue, the item with the highest priority is going to be removed first. And currently, this item is going to be removed first because it has the highest priority and it came before this other item with the same priority level. So let's see what we have. So we have value is equal to pq dot dequeue. And we'll print value and run it. So you can see this item was removed. If we perform another dequeue operation, it is going to remove this other item. So let's copy this and paste it below and run it. So you can see currently we have 2 items, both having the same priority of 2 and 2. So if we perform another dequeue operation, the first one is going to be removed. So let's copy and paste and run it. So this was removed. So this is basically how the priority queue works. And with this, we'll conclude our lesson on stack and queues.